let us solve a couple of more problems of trigonometry using complex numbers. Solve. Now you know the trick, so you will be able to solve this problem relatively quickly. Maybe this is, let me call this as third problem. Cos x plus cos 2x minus cos 3x is equal to 1. Solve the equation. Soumya is waiting. Okay, I give you 7 minutes and then we discuss the first thing that we need to do is consider z is equal to cos x plus I sin x. Correct? Therefore, this is our starting point for earlier problems also. Therefore, cos x is equal to z square plus 1 upon 2z. Cos 2x is equal to z raised to 4 plus 1 upon 2z square. Cos 3x is equal to z raised to 6 plus 1 upon 2 z raised to 3. So the given LHS is equal to z square plus 1 upon 2z plus z4 plus 1 upon 2z square minus z raised to 6 plus 1 upon 2z cube. And we are required to prove this is equal to 1. That is to prove that. Okay. So what do you get after simplification? We can take z raised to 3 common. So LHS, RHS I can say 2z cube. What is in LHS? Z raised to 4 plus z square plus z raised to 5 plus z minus z raised to 6 minus 1. Is that right? So there are how many terms now? Z cube also, if we put it at this side, then we get, and we make z raised to 6 the largest power positive, then we get z raised to 6 minus z raised to 5 minus z raised to 4 plus 2z cube minus z square minus z plus 1. Is that right? Is equal to 0. Now I think this gets factorized.
सर 2z cube ला z cube आणि z cube ने split करायचं.
z minus 1 factor common.
Factors. So z raised to 3 inside bracket z cube minus z square minus z plus 1 plus 1 inside bracket z cube minus z square minus z plus 1 is equal to 0. That gives us z cube plus 1 is equal to 0. Or do you factorize this into 2 factors or 3 factors again?
Sir, z square minus 1 आणि z minus 1.
ह्याचे फॅक्टर्स पडतात?
हो सर.
z square minus 1 and z minus 1.
Z minus 1 bracket square.
हो.
sir.
Is equal to 0. Okay, so we are done almost. Therefore, this implies z cube is equal to minus 1, or z is equal to minus 1, or z is equal to plus 1. And this will provide us with three solution sets. If z is equal to plus 1, so our z was cos x plus I sin x. Therefore, if z is equal to 1, then cos of 0 or 2 pi, or so this will provide us the solution set. Uh, this will provide us the solution set. Z is equal to plus 1 is 2 pi k, where k belongs to z. This is the solution set of this expression. What will be the solution set of this expression? It will be pi plus 2 pi k, where k belongs to z. Okay, and now let us look at this. What are the roots of this? Z cube is equal to minus 1. So this is your minus 1, and cube roots of minus 1. I can
minus omega and
minus omega minus omega square.
minus omega minus omega square. Okay, and their corresponding multiples. Therefore, solution set of this can be generalized and written as 2k plus 1 upon 3 times pi, where k belongs to z. बघा बरोबर आहे का? If k is equal to 0, you get pi by 3. Correct. If k is equal to 1, you get pi. That is the solution. Yes. If k is equal to 2, 5 pi by 3. Correct, na?
No, sir.
So union of these three is your solution set. Good. Now let me give you a difficult one now. Difficult one. थोडं छोटं करून ठेवतो बोर्डवर, काही जणांचं लिहायचं राहिलं असणार आहे. Show that. I wait for 10 minutes. Okay, the starting point is same. Starting point is z is equal to seven. So if this is the case, then z raised to 7 plus 1 is equal to 0, right? And z is not equal to 1, not equal to minus 1, and z raised to 7 plus 1 can be factorized as z plus 1 into z raised to 6 minus z raised to 5, z raised to 5 plus z raised to 4 minus z raised to 3 plus z raised to 2 minus z plus 1 is equal to 0. Now z is not equal to minus 1, therefore this factor, maybe I am just taking another route for solving this. I think majority of you guys have tried to express cos pi by 7 in the cos pi by 7 is equal to z square plus 1 upon 2z, z fourth, and then simplified. That is correct. If you get the answer right, it is correct. Okay, but then I'm just taking another route and showing you another interesting property. So if z is not equal to minus 1, makes it z raised to 6 minus z raised to 5, z raised to 4 minus z raised to 3 plus z square minus z plus 1 is equal to 0. Okay, and therefore look at this step. Z raised to 6 minus z raised to 5 plus z raised to 4 plus z raised to 2. Nah, come on. Suppose I take z raised to 3 common from first 3. I get z raised to 3 minus z raised to 2 minus plus z, and we have minus, काय करतोय मी, एक मिनिट. If we take minus 1 common, we get z raised to 3 minus z square plus z is equal to minus 1. Is this correct? Which is equal to z raised to 3 minus 1 into z cube minus z square plus z. Now, why I am interested in this factor is because this bracket looks like this. Not the bracket, but then the real part of the bracket looks like this. So I am interested in this. And therefore I took out z cube minus 1 common, and then is equal to minus 1. That makes it z cube. That makes it z cube minus z square plus z is equal to 1 upon 1 minus z cube. Okay. And now this is a complex number. This is also a complex number. So if we look at, because the given problem is real part of this complex number. Do you agree? This implies real part of z cube minus z square plus z should be equal to real part of 1 upon 1 minus z cube. So this is what is our LHS. So if we prove real part of 1 upon 1 minus z cube as half, we will get RHS. Okay, so the lemma or some small problem, if z is equal to cos t plus I sin t and z is not equal to 1, then real part of 1 upon 1 minus z is always half. Prove. 3 minutes. We have to prove real part of this is always going to be half. What do? You write down z is equal to cos t plus I sin t. So consider 1 upon 1 minus cos t plus I sin t, which is equal to 1 upon 1 minus cos t minus I sin t, is equal to 1 upon 1 minus cos t is 2 sin square t by 2, and how much is this? Minus 2 I sin t by 2 cos t by 2, बराबर, which is equal to 1 upon 2 sin t by 2 inside bracket sin t by 2 minus I cos t by 2. Now we have to rationalize. So sin t by 2 plus I cos t by 2 upon 2 sin t by 2. Now if you multiply these two guys, what will happen here? Sin square t by 2 minus minus I square. Right, na? So what will happen to when you multiply? Will it be 1?
Yes. Yes.
It is sin square t by 2 plus cos square t by 2, which is 1. That makes it real part is separate now. Real part is sin t by 2 upon half sin t by 2 plus I times cos t by 2 upon 2 sin t by 2, which is half plus I something. And therefore the real part of this is always half. Understood? Okay.
आधीच रॅशनलाइज केल्यावर सोपं पडतं.
आधीच करायचं का?
हो सर, ते त्याच वेळेला केलं तर सोपं पडतं.
चला. Next problem. Which color should we use now? Yes, सगळे निळे झालेत. Let A be a positive real number. Let MA is equal to all those z's belonging to complex numbers such that z plus 1 upon z absolute value is equal to A, bracket complete. Find minimum and maximum value of mod z when z belongs to MA. Okay, I give you 10 minutes to think and try your level best, else we will discuss. I mean, you must have used some other method, but I have a method by which I can explain you some trick also. Now, basically, you want to deal with this. This is bad color. Let me change the color. This this. Let us see how it looks. Mod z, a is equal to mod z plus 1 upon z. Okay, this implies a square is equal to mod z plus 1 upon z bracket square. And now when we have a square like this, what do? We say z plus 1 upon z into z bar plus 1 upon z bar. That is, this is equal to a square. And then we start simplifying. Z bar plus z upon z bar plus z bar upon z plus 1 upon z bar is equal to a square. This is equal to mod z square plus 1 upon mod z square and now suppose I multiply this by z, I get mod z square in the denominator and z square by mod z square in the denominator plus z bar square upon mod z square. I have taken care of all four and it is equal to this, which is equal to. Now if I clear the denominator, or maybe if I simplify the denominator, I will get mod z square and I end up getting fourth degree mod z raised to 4 plus, now I have z square plus z bar square and I would like to write that as z plus z bar bracket square. So I have created z square, I have created z bar square, and in addition I have created 2z bar which I should subtract, which is 2 z bar is 2 mod z that I have subtracted plus 1 is equal to a square, right? And therefore if I take this z plus z bar to the RHS, I end up getting mod z raised to 4 minus, no, this is mod z square because it is z bar, right? And therefore mod z raised to 4 minus mod z raised to 2 inside bracket minus a square minus 2. So I bring this a square also this side plus 1 is equal to opposite of z plus z bar bracket square. What is z plus z bar? Real part of z, 2 times real part of z. So this is a real number, this is a real number and it is a square of a real number with negative sign here. Therefore I get inequality mod z raised to 4 minus, or if I take minus sign inside, is it correct? Whatever I am doing, minus z raised to 4, this goes to the other side, this comes to the LHS, and therefore बरोबर चाललंय ना?
सर तिकडे a square plus 2 असायला पाहिजे ना?
आतमध्ये स्क्वेअर प्लस 2 पाहिजे का?
तर कारण बाहेर आपण मायनस
हा, बाहेर मायनस कॉमन काढले ना, बरोबर. I was expecting that. So a square plus 2 times mod z square plus 1. This RHS is going to be either 0 or less than 0. Therefore this should be 0. That is the inequality that we have got. And therefore this is quadratic in mod z. I mean biquadratic in my mod z, but it is as good as quadratic in mod z. Therefore we can get mod z. Now leading coefficient is 1 positive. Therefore this is graph like this. and you want it to be less than or equal to 0. Therefore, you are interested in this point, and all the points between. So mod z raised to 2, that is the root of this mod z square, will belong to mod z square will belong to closed interval. चला कडा बघूया ह्याचं काय आहे ते. These points, find the root of this biquadratic. You write down these two quantities here. I wait for 2 minutes. करा प्रत्येकाने. Write down the roots. Let me write down the roots. Inside bracket I have a square plus 2, that is minus b, plus minus पैकी minus आधी लिहूया, minus radical b square minus 4ac is a raised to 4 plus 4a square upon 2, and the second point is a square plus 2 plus radical a fourth plus 4a square upon 2. Okay, so I park this problem here. Now suppose I say that x square belongs to closed interval 4 comma 9. X square belongs to closed interval 4 comma 9. Can you tell me the minimum value of x? And can you tell me maximum value of x?
Sir, minimum -3 and maximum +3.
What is the minimum value of x and what is the maximum value of x? Can you tell me if x square belongs to 4 comma 9?
-3 and +3.
-3 आणि 3.
+3.
-3 is minimum value.
Minimum value.
And what is maximum value?
+3.
3. Okay. And what are the other two values also available? I mean, -2 and +2 are also available here. Okay. So therefore, let us check whether this we can find out the square root of this or not. So find out square root. Find out a square root of this quantity as well as find out square root of this quantity and get me 4 numbers. Then we will compare and decide who is minimum, who is maximum. Here x, if I find out square root of 4, it is -2 comma 2, and if I find out square root of 9, it is -3 comma 3, and then I decide amongst these 4 numbers, this is minimum, this is maximum. Like that, we want to answer for mod z. Therefore, you need to find square roots of this. So find square root of this and find square root of this. Then we will compare and decide. 3 minutes. If you take square root of first quantity, it is root of a square plus 4 minus a upon 2 comma minus root of a square plus 4 plus a upon 2. These are the two roots of first one, and two roots of second are radical a square plus 4 plus a upon 2 radical up to 4 and minus radical a square plus 4 minus a upon 2. Baga, are you getting these 4 numbers? And all 4 are different, they are not same. Okay, and now you have to keep in mind that this is mod z. This is mod. If I would have asked you the question here, what is the minimum value of mod x and what is the maximum value of mod x, then what would have been the answer? Minimum value of mod x would be 2 maximum value of mod x will be
V.
3.
okay. So now we have to find out which one is, first of all, is this quantity positive? Yes, because if this 4
Yes.
is not there, then it is root a minus root a is 0. Therefore, if 4 is there, this quantity is bigger than this. Therefore, this quantity is positive. Is this quantity positive? No, because the first quantity is bigger than a. Therefore, this quantity is negative. Is this quantity positive? Yes, this quantity is positive. Is this quantity negative? Yes, this quantity is negative. Therefore, we have two positive and we are discussing mod z. Therefore, one bigger amongst these two will be the maximum value and the smaller amongst these two will be the minimum. So, minimum of mod z is equal to this. Radical a square plus 4 minus a upon 2. And maximum mod z is equal to radical a square plus 4 plus a upon. So what is the learning value in this problem? In this problem, the learning value is this step. This step here. The learning value is this step here and this step here. Because this quantity is negative. So this is suddenly the equation becomes very simple. Otherwise, we will have to look for what do we do with the z and z bar. It is x plus iy and x minus iy, and therefore we are in trouble. So suddenly we realize that this is a real number and it is a square of a real number. Therefore, this quantity is positive, which is with minus sign. Therefore, RHS is definitely negative, or worst come worst, it will be 0. Therefore, LHS becomes less than or equal to 0. Okay. So, I am almost done as far as complex numbers are concerned. Now, only some part related to geometry, that means what is the equation of straight line in complex numbers, what is the equation of circle in complex numbers, how equation of circle looks like, what would be the equation of perpendicular bisector, etc. These are the geometry related complex numbers is pending. That is, as far as your IIT syllabus is concerned, that is the thing which is there in the IIT syllabus, but we have not done it. But I am not planning to do it right now, because if I am doing straight line circle, then I have to stop at circle. I cannot do parabola, ellipse, hyperbola. How the equations of parabola, ellipse, hyperbola look like in complex numbers, because parabola, ellipse, hyperbola in two-dimensional geometry is not discussed yet. Therefore, maybe I will stop at this point, and we have done much more than so far. I mean, in foundation, we have not discussed complex numbers in such a detail. With last 3-4 lectures, whatever problems we have solved are being solved for the first time in the class. Okay, so now one thing that you can do is, if there are any really interesting and difficult problems in the problem sets that you are solving right now, I hope you are solving, we can discuss those problems in the class, or you can put the solutions. Somebody is asking questions, somebody is putting the solution. That is good thing which is happening, and maybe I start discussing vectors from next lecture. So
Sir,
think on it and let you know. I mean, you will come to know in the beginning of next lecture only what is my plan.
सर
Yes.
सर तुम्ही 9वी मध्ये सांगितलं होतं की अँगल बायसेक्टरचं इक्वेशन म्हणजे कुठला ॲक्यूट आणि कुठला ऑब्च्यूज ते तुम्ही ट्रिग्नोमेट्री मधून सांगणार आहे.
चालेल, चांगलं सांग, आठवण करून दिली असतो. फक्त मग ते आता 10-15 मिनिटात काय होणार नाहीये ते. 20 मिनिटं आहेत आपल्याकडे. काय करूया?
सर मला पण एक डाऊट होता.
हम्म.
सर आपण समजा आपल्या ट्रिग्नॉमेट्रीमध्ये इक्वेशन होती की साइन थिटा इज इक्वल टू 2. सो आपण त्याला नो सोल्युशन्स इन रिअल नंबर्स लिहायचो. त्याला कॉम्प्लेक्स मध्ये सोल्युशन्स राहू शकतात का?
नाही. साइन इज अ बाउंडेड फंक्शन आणि मॅक्सिमम व्हॅल्यू इज 1, मिनिमम व्हॅल्यू इज -1. यू विल नेवर गेट एनी अँगल वेदर I mean I don't know because I have not studied complex analysis, but I think that sin theta is equal to 2 will not have any answer. That is what my intuition is. I have not studied it. But if at all it is having the answer, I think it is beyond MSc mathematics question. That is what is being asked. Okay. And maybe I will think about it. Can I really, with the given complex number background, can I really have a solution for sin theta is equal to 2? But it is way beyond our scope of study. Okay. I know only mathematics up to IIT JEE advanced, nothing more than that, because I am chemical engineer. Whatever is required for your IIT JEE advanced, it is available with me in plenty without any problem. But if you really ask me deeper questions in mathematics, I am not MSc mathematics or PhD mathematics. I am BTech chemical engineering. Therefore, you are not supposed to ask me neither deep mathematics questions nor deep chemistry questions, because I am not deep in any one of them. Okay. So okay, so I don't have anything to do in next 15 minutes. Therefore, we will discontinue this meeting. No problem. If you have any other things to discuss with me, काय तुम्हाला अजून काही शंका असतील, तुमचं काय, तुमची शाळा वेळा काय सुरू होणार आहे, परीक्षा वगैरे होणार का नाही 10वीची तुमची?
ऑनलाईनच आहे सगळं.
अरे थांबा, रेकॉर्डिंग कशाला करून ठेवतोय? ते रेकॉर्डिंग स्टॉपच करून टाक.